Welcome back, class, to another video. We are continuing our work on quadratics and parabolas, and today we focus on projectile motion. Alright, so this concept of projectile motion, I hope you're not scared by it. I know you guys have, well, I'm pretty sure you guys have done some of this with physics. What I want you to understand is projectile motion is just quadratics. It's just parabolas. Okay? So that's what we're gonna work with. So first thing we have to do is we have to set up our projectile motion equation. Okay, it's always going to look like this: h of t equals negative 16t squared plus v naught t plus h naught. Okay, and if we think about this, we know what a lot of these letters and numbers represent. Okay, what do we say? This is our height at some time. Okay, the negative 16 we know, what's that? Anyone remember? That's acceleration due to gravity. So that's important. I'm going to skip t for a second. We're going to get there in a second. To do v naught, this is initial velocity. And lastly, h naught is initial height. Okay, so let me move my hand for a second so you guys can see all of that. Alright, height at some time. Acceleration due to gravity is why we have this negative 16, and that's never going to change with what we're doing. Then we have initial velocity, which is going to change, and initial height. Last thing that I didn't talk about early here, guys, t we know is time. Okay, our function is in terms of time. Height is in terms of time. So, units here, we have a bunch of them. Height, well, height should always be in, with what we're doing, we're going to be using feet. Okay, height should always be in feet. T, or time, should always be in seconds. The last one, velocity, if we ever solve for velocity, which we might do, it should be feet per second. Alright, so height is in feet, time is in seconds, and then velocity would be feet per second. Last thing we want to do, just to kind of get started and hopefully understand what we're looking at here, is again, all of these graphs are going to be parabolas. Parabolas, parabolas, parabolas. Similar to what we did in maximizing area, we knew that our function was, well, last chapter, our function was area, correct? An area function, so area was along the y-axis. Now we're in height. So here's height along the y-axis. And then if it's h of t, then we need t along the x-axis. So this will be time, this will be height. And then the last thing, I want you guys to understand this, and hopefully this is starting to make sense to you, and maybe it made sense to you last chapter too. The a value, or the coefficient on t squared, was always negative. That's what allows it to open down. That's what we need. That's how projectile motion works. We start somewhere, we go up, 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 and then we come back down. Alright, that is how projectile motion works. Now the last thing we need to know here, this is always going to be our h naught value. Okay, h naught is always going to be the y-intercept. Okay? Ooh, one more thing let's add. Let's say we're still going to be working with h and k, so let's add that to our picture as well. Okay, so let's jump into an example. Let's see how this works. Giselle fires an arrow straight up from the ground with an initial speed of 200 feet per second. Its height, h after t seconds of flight, is modeled by the equation, blah. Write the appropriate equation. Alright, so let's kind of put some of this together. We know we're writing an h of t, a height function. We said that acceleration due to gravity will never change. Here we go though. We have an initial velocity. It tells us 200 feet per second. Do we have an initial height? Let's read again. Giselle fires an arrow straight up from the ground. Ooh, from the ground. From the ground means what? h naught is equal to 0. So I am all done. I do not have an h naught for this problem. Actually, I do have an h naught. It's 0. So I do not need to add a 0 to my function. We are good with this. Okay? As we move on to the next piece, it says to draw a labeled graph. Okay, this is similar to what we did last chapter. It's just not area anymore, it's height. So we have time, we have height. This is where you need to kind of make one little connection before you sketch your picture. Because our h naught, or our height, our initial height was 0, we are going to start right here at the origin and go up and come back down. Okay? Because we are starting at a height of 0, our y-intercept has to be 0. Okay? Let me write that. h naught equals 0. Okay? Cool. If we read ahead, it says that we're looking for max height, and what time does it reach the max height? So we're going to need some information about the maximum. And if you remember correctly, we can use our formulas to help us out with that, okay? So what is the maximum height? Well, you have to make the connection. Maximum height, or height in this case, is a y coordinate, or sorry, a y value. So if we're looking for the y value of the maximum point, is that h or k? That's the k value. Okay, that's the k value. We want the y value of the maximum. So we need to use k equals c minus b squared over 4a. Alright? K equals c minus b squared over 4a. Let's do a little bit of work here. Plug some stuff in. 0 is my c value. I have 200 being squared. Ooh, okay. And what else do I have? I have 4 times negative 16. Okay, first thing I'm probably going to do is understand that I have a negative and a negative, so let's just make those positive now to help us out. And now we have to start doing some simplification work, okay? One thing I know for sure is I can do 204. Let's see, that's 50 and 1. 50 and 1. What else can we do? Let's see, 216. I can take out, what do we want to take out? Maybe an 8? Let's try that. If I take an 8 out of 200, I'm left with 25. If I take 8 out, I'm left with a 2. Alright, so let's clean this up just so I can stay a little bit organized. I have a 50 and a 25 still, so 50, 25, and then I just have a 2 in the denominator. Okay, I'm going to do one more calculation. I'm going to say I can reduce this to 25 and 1. So now I know that k is going to be equal to 25 times 25, or 25 squared, which I hope we know is 625. Okay, 625. Last thing, guys, please remember, need units. We're talking height, and we said what at the top? Height's going to be in feet. Okay? So now we know that our k value is 625 feet. At what time does the arrow reach that height? Well, now we know time is an x value, okay? So we're looking for the x coordinate of our maximum height. So we need the h value, which is the x coordinate of our maximum. And how do we do that? Well, this one's even a little easier. What do we got? We have negative b over 2a. So let's see here. Negative 200 over 2 times negative 16. Once again, I'm going to just kind of cancel out my negatives or make them positives, however you want to think about it. And then I can start to reduce. I'd say the easiest one is making this 100 and this 1. Let's see. I can definitely take out a 4 from the 100 and the 16. So let's do that too. I know it's getting a little messy, but I can do that. So now I know that I at 25 over 4, I can't reduce that anymore. I would probably want to just kind of simplify that radical, or not radical, sorry, simplify that fraction and try to turn it into something that we can use a little more than an improper fraction. So I know what 4 goes into 25 6 times, and then there's 1 left over. So I can go 6 1/4. I can also say 6.25, however you want to represent that. But then again, this is time, so this should be in seconds. All right. Last problem over here. At what time does the arrow reach the ground? At what time does the arrow reach the ground? Okay. Be very careful here, guys. I don't know if you remember from the last video, but we kind of gave you a box that we're going to introduce again on the next page. I need you to understand what type of situation this is. When it reaches the ground, if we go back up to our picture, reaching the ground is right here. Okay, that's an x-intercept. We're looking for an x-intercept, and when we're looking for an x-intercept or a solution, we have to set y equal to 0. Okay, so we're going to say 0 equals negative 16t squared plus 200t, and I need to solve this. I need to factor this. I need to get my solutions. So we keep going. I'm going to factor a little bit, or I can take out a GCF. Let's see here. What can I take out of both? I know for sure I can take out a negative 8t. So I think I'm going to start with that. If I take out a negative 8t, that leaves me with 2t. And what do we have here? If I take out negative, so minus 25? I think that looks good. Okay. So we're ready to solve this. We can use the zero product property. We know that if we use this factor, we get a t of 0. And we also, from this factor, we get a t of 25 halves. What I need you to think about here is this t we already knew, right? T equals 0, we knew that it was starting at the ground. This is not the time we're looking for. We're looking for the time over here, which is why we're going to say 12.5 seconds. And again, all I did was I did 25 divided by 2 in my head. Okay? All right. So what I was trying to get at on on that last problem, we talked about this in last video. There are 3 things that we're really going to be asking here in terms of parabolas and quadratics. I either am going to want a min or max, which is the vertex. So you need h and k, and we know that we can either use what? Vertex form, which means you need to complete, sorry, I know I'm writing too much, complete the square. So that's one option for finding the vertex. Or a lot of the times we'll use h and k formulas. If we're trying to find when there's a specific value or a specific height, in this case with projectile motion, well then you just set y not equal to 0. You set y equal to the value and solve. Sorry about that. And then lastly, 0 root x-intercept. This is when you set y equal to 0 and solve. Okay, so those are our 3 situations. Let's see what's going on in this next example and try to figure out which situations we're looking at for which problems. Okay, so here we go. Baseball is thrown straight up into the air. Its height in feet above the ground after t seconds is modeled by h of t equals negative 16t squared plus 40t plus 5. Okay, so use what we know about our function. V naught t plus h naught. Okay, and we need to figure out what is the initial height, what is the initial velocity. All right, we'll just use the equation, the general equation, and what's given to help. I know that this is initial height, excuse me, I was going to say h naught, initial height. So my initial height is 5 feet because that is what corresponds in our given function. Initial velocity, well, v naught, 40 feet per second. All right? So now when we sketch a picture of this, only one thing is going to change between our picture on the other page and this current picture. Okay, the axes don't change. This is still time. This is still height. The only real difference, guys, that I want you to make sure that you take into consideration is the initial height. Okay, the initial height is not 0 anymore. It's 5. So you cannot start your graph at the origin. You have to start a little bit off the origin or up from the origin. So something like this. All right, this should be at 5. And we know that we can get a maximum if the question is asking for it. So let's take a look. Oh, there we go. Letter D. What is the maximum height the ball will reach? Okay, maximum height. Height is a y value, which means we want the k. Okay, we need to use our k formula. K formula says what? K equals c minus b squared over 4a. All right, well, our c value is 5. Our b value is 40. And then we have 4 times negative 16, which is a. Okay, so we can definitely make both of these pluses. I think that might make it easier on us. Let's start canceling some stuff out. Okay, so I can definitely go to 10 and 1. That's nice. What else can I do? 16 doesn't go cleanly into 4, but we could do maybe take out an 8 from each. So if I take out an 8, I'm left with 5 and 2. All right. Last thing, I have one more. I have a 10 and a 2. So I'm going to make this a 5 and a 1. All right. So I know that gets a little messy, but if you go step by step, it shouldn't be too bad, because now I see I have no denominator, right? 1 and 1. I do have 5 and 5 in the numerator. So this will be 5 plus 25. 5 times 5 is 25. 5 plus 25 is 30 feet. That is my max. Okay, 30 feet. Oh, sorry, off the page. Okay. E is a good example of number 2 from above, okay, or number 2 from our review. I'm giving you a specific height that I need to kind of figure out some information about, okay? So, this is what we are going to do. We are going to say that we want our height to be 29. So, height needs to be 29. We set it equal to our function. What was it? 40t plus 5, okay? And we need to solve this, okay? To solve this, a quadratic, usually we like to factor, right? And I usually like my a value to be positive, so instead of moving the 29 over, I'm actually going to move everything to the left. Left. So that means I'm going to have a positive 16t squared, a negative 40t, and a positive 24. And that's going to be equal to 0. Now I have to factor. I have to solve this guy. Make it easier on yourself. This looks really hard to factor right now. Take out a GCF. I see an 8, an 8, an 8. So let's take out an 8, which leaves me with 2t squared minus 5t plus 3. This is so much more manageable. Okay? If you need to, you can absolutely factor this by grouping. I know that's how we did a lot of these. When there's just a 2 in front, I'm going to save some time, I'm just going to go right to the factoring. Okay, so 2t and t, I know that because these have to multiply to 2t squared. I know that both of my values have to multiply to positive 3. And because this is a negative 5, I know it's going to have to be minus minus, which is very important. The last thing you need to consider here is which one is going to be able to be multiplied by this 2. Do you have to put a 1 here or a 3 here? It's going to be the 1, which means this is going to be the 3. Remember, when you do outsides and insides, it has to add up to the b. So when I do 2 times negative 1, I get negative 2. When I do negative 3 times t, I get negative 3. Negative 2 and negative 3 combine to negative 5t. So we are good. Last thing, we need to kind of get these actual times. Well, t is going to equal 1. Very nice from that one. And then this one's actually going to be pretty nice too. It's 3/2, or 1.5. The reason I'm doing this is because now I can kind of put those points on my graph, right? And maybe I should do this too. I'm going to put a little dashed line. All right, I know that this is a height of 29. So what I want here is I want it to be greater or equal to 29. So I put closed circles. Why do I close them? Greater than or equal to. Greater than or equal to means that I want everything between these 2 points. Okay, so I know the times there. I know one of the times was at 1. This one is at 1.5. So when I go to write my interval, my time interval, I'm going to say that I am going to go from 1 to 1.5. And the last question here is, do I close or keep the brackets open? Closed brackets are open. And the answer is I close them because it's allowed to equal 29. At a time of 1, it's exactly 29. At 1.5, it's exactly 29. And that is okay because of our statement. All right? Okay. Last page. We're getting there. Last page. Okay, so let's read this. Deep is sitting in a pit 4 feet deep and wants to shoot a rocket that will reach 60 feet high. All right. Interesting. Well, first thing we should probably do is get an equation, draw a picture, kind of think about what's going on here. All right. What's going on? Deep is not on the ground. He's not above the ground. He's actually below the ground. He's in a pit. All right, so maybe he's something like this, and he's shooting a rocket, something like that. All right. What else do we know? We know that we want to get to a height of 60. We know that we're trying to get to a height of 60. Oops, sorry, my picture's off the graph, or off the page, sorry. All right, so let's think about what's going on here. We need h of t to equal acceleration times squared. We do not know a velocity. Okay, like read through this, you hopefully agree with me. We do not know velocity. What we do know is that he's sitting in a pit 4 feet deep. That's 4 feet below ground. So this is actually a negative 4. Okay? So we have everything that we need except initial velocity, and what do you know? In the next question it asks, what should we make the initial velocity to ensure that the rocket will reach 60 feet? Well, think about this. At 60 feet, this will be the maximum, and 60 is a y value, okay? 60 is a height, or a y, at the max, which means take all of this information and say, I want the k value, okay? I need the k value to equal 60. So we're going to work a little backwards here. Now we have the k value. We know k, which is equal to c minus b squared over 4a. When we plug some stuff in, sorry guys, that's an a, I know that it's going to be 60 equals, well, c is negative 4 minus, I don't have b, or I know b is actually my v naught. So I'm going to say v naught squared over 4 times negative 16. All right. Let's see what's going on here. Okay. First things first, to start solving this, we're probably going to want to move the 4 over. So 64 equals negative v naught squared over 4 times negative 16. All right, what can I do? I can make both of these pluses for sure. at this point in time, remember, you don't have a calculator, which is tough. I'll give you that. But you can do this. We know what we should be doing. We need to get this over to the other side, right? Right now we're dividing by 4 times 16, which means to move it over to the other side, we have to multiply by 4 times 16 on both sides. All right, so that's going to cancel. And now I have that v0 squared is going to equal 4 times 16 times 64. Okay, this is scary, right? We don't know how to do this. Wrong. You do know how to do this, okay? You know that when you have the square of something, to get rid of it, you have to square root both sides, okay? This is perfectly okay. When you have factors underneath a square root, you can take them out individually, right? So just look at each piece. All right, when I square root v0 squared, I get v0. When I square root 4, I get 2. When I square root 16, I get 4. When I square root 64, I get 8. Now this is manageable. 2 times 4 is 8. 8 times 8 is 64 feet per second. All right, you can do this. You can do this. Last part, how long does it take for the rocket to reach this height? Well, how long? This is time. And we're talking about the max. So, h. We want the h. Oh, sorry, I'm off the page a little bit. Sorry about that, guys. We want the h value. And we know that h is going to be opposite b over 2a. So let's plug in. Well, we just got the b value is 64. So we're going to say negative 64 over 2 times negative 16. First things first, plus plus, right? Make sure we understand how those negatives change. And then I would just start simplifying, okay? You have options. I could do 32 and 1. And then what else could I do? Let's change colors. Ooh, 2 and 1. This was nice. Okay, we know that our h value is 2 seconds. So, t is 2 seconds. All right, so what did we do? We completely focused on projectile motion today. Hopefully you guys understand that it's really just all of the same stuff that we've been doing with quadratics. It's really just a quadratic, so we have to use our h and k formulas. Have a good day.